Welcome to Ask Caleffi, the podcast that dives into real-life problems that plumbing and HVAC technicians face in the field. We're your hosts from the Caleffi Tech Support Team. I'm Greg Tubbs.
And I'm Dan Furcus. Welcome. We look forward to sharing some stories from our tech calls and using our background and expertise to make your days a little easier.
Hey, welcome back to the Ask Caleffi podcast. This is episode 5. We're talking hydraulic separators today. How we doing, Dan?
We're doing good. Yeah, hydraulic separators are a big topic. We get a lot of calls on those.
We certainly do. How to pipe them and just the explanation of hydraulic separation, the concept of it.
Right, yeah.
So what is hydraulic separation? Let's dive in right there.
Yeah, I mean, it's a good place to start. You know, hydraulic separation was a concept that was brought in the early 50s by Gil Carlson from B&G.
Yeah, that's right. Way back when.
Yeah, it was kind of the innovation of primary, secondary piping in boiler systems, you know, where he realized or discovered that putting closed space T's in created 4 connection points that were close enough together that you could have a pump on either side, and that either pump could come on or off at any time without affecting the other one.
Right. So he essentially built a decoupling system by sweating together closely spaced T's to pumps to come on and off without conflict.
Yeah, absolutely. It was a way to control flow on either side without affecting the other. You know, from there we expanded and started adding buffer tanks.
Right. Yeah, buffer tanks. I mean, it gives a boiler more room to roam, so to speak. It allows it to have more capacity, especially for
added volume to the system.
Yep, adding volume to a system where there might be micro zones.
Yeah, especially when you had micro zones, that's where you saw the buffer tanks being added, because by adding volume, you know, essentially it's a big hydraulic separator where you have the velocity instantly drop, so you don't have interference between the microzone and the boiler. You can maintain your design flow rate through your boiler while having a microzone running at a smaller flow rate, and one doesn't affect the other.
Right. And I think the hydraulic separator is always commonly, the conception is kind of construed that you could use it as a buffer tank.
Yeah, I mean, it's not exactly a buffer tank. It's definitely a smaller volume, a lot easier to pipe.
Yeah.
I mean, when you look at, you know, mechanical rooms getting smaller and you want to achieve, you know, hydraulic separation and you want to have more volume in your system than closed space T's will provide, but you don't have that space for a buffer tank or really need the volume of a larger buffer tank, a hydraulic separator is a great solution.
Right. It's that IBeam Shape. It's pretty much, it's engineered. It's ready to go. It takes up way less space. You hang it in your piping or on the wall on a bracket.
Yeah, and that IBeam Shape that you mentioned, you know, the body of that is typically 4 times larger than the pipe connection size. So that's where you get that instant velocity drop, instant decoupling of the two sides.
Sure. The benefits of using a hydraulic separator. Let's talk about that. I mean, we both know it takes a ton of time to cut pipe, measure, sweat things together, make sure it doesn't leak.
Make sure they're spaced properly.
Make sure they're spaced properly.
That's a big thing.
That is. I mean, and you and I both have been there. We've worked with guys that, close enough, it'll work.
Yeah.
And somehow it does.
Well, it does. I mean, you can really pipe a system wrong and it'll work to some extent, but let's face it, we want to get this right.
Yeah, get it right, save time on the job, less chance of leakage, you know, at a ton of solder joints.
Right. So you look at our hydraulic separator and all of that is factored in. So when you talk about labor savings, you know, you already have the body of with 4 connection points, 2 on the left, 2 on the right.
Yep.
You know, and essentially you're going to hook your boiler or your source side to one side of the separator and your system or load side to the other side. It doesn't matter what side it's on, left or right, as long as your supply and return for your load and your supply and return from your source are on the same side of the body.
Right. And then your hot ports are at the top and your cold ports are at the bottom.
Yeah, that's kind of our general rule. Hot on top, cold on the bottom.
You got it. So we offer essentially 2 models of hydraulic separator. We have the 548, which is just a standard hydraulic separator. It's sold on the premise of number one benefit, hydraulic separation. Yep. And then, yes, it has an air vent on top. It has a float type air vent on top, but that's really not going to remove the air bubbles. It's not going to remove entrained air because all we have is a diverter plate in the flow path there. We don't have a coalescing mesh.
Right. Yeah. We talked about air separators a couple weeks back, and you're right. It doesn't have the coalescing mesh, so it's not a separator. It does have the auto air vent we talked about, a few weeks back, where it'll let air out of the body of the separator, but it's not designed there to take the place of a system separator.
Right. It's just taking whatever is in that barrel, the larger bubbles, and it's allowing them to escape.
It does have a stainless steel baffle in the middle, which helps with flow path and control, but it's not designed to remove air.
Right. So
we'll also have that drain on the bottom.
Yes, it does. And another thing we get asked too is, will this thing remove dirt? There's nothing in there to divert any dirt out of flow path.
No, there isn't. But again, when you look at the bigger body size and the velocity drop, because of the velocity drop of the water, dirt and particles will have, a natural ability to fall.
Gravity.
Yeah, gravity to fall. Just like air will have the ability to rise. So, having that air vent on top removes air from the separator itself. Having the drain on the bottom allows you to purge off the separator and pull any debris that might fall into the bottom.
Definitely. So it's still better than your grandpa's closely spaced tees by far.
It sure is. A big labor savings.
Yep. Well, we've got that. And then we have the 549. So the 549, the SEP 4 is our all-in-one.
Yeah, it is. That's the Cadillac.
It is. I like that product.
I do too. I don't know why that's not in every system.
Yeah, and honestly, I wish I would have had something like that back when I was installing, because it just makes a ton of sense.
It's easy.
It is easy. You don't have to find space to fit in an air separator anymore.
Right. Well, we should talk about it.
Okay.
All
right.
You look at the 5495, that SEP 4, that's a 4-in-1. Mm-hmm. So that is providing the hydraulic separation that we talked about with the 548. It's going to provide air removal, but now has the coalescing mesh in it. So it is an air separator.
Yep.
So, it's not just an air vent for the body of hydraulic separator. It's actually a system air separator.
It's a system air separator. And then the added bonus is that coalescing mesh in the bottom with the magnet and the purge valve again, to be able to remove any dirt and debris. It'll catch ferrous material.
Yep. So, magnetite.
Yep. Magnetite. So if you're running DC pumps,
variable speed pumps it's
saving that rotor. It's saving those pumps. That wet rotor is not catching all that magnetite out of the fluid anymore.
Right. The magnetite's going to end up somewhere. It's either going to get pulled out by our separator, or it's going to end up in your variable speed drive.
Yep. Or in the low points of your boiler heat exchanger, which that's the other reason for using something like this.
Yeah,
protect your boiler, protect your pumps.
Yep. Well, and then you look at, convenience. I mean, this is an all-in-one 4-port connection. You pipe your supply from your boiler out into the top of one side of the separator, out of the bottom back to your boiler with the return. The load side, you're coming out the top, out to your load side supply on the one side of the other side, and then return coming back into the bottom on that same side. No air separator to locate, no dirt or magnetic separator locate. It's all there in 4 connections.
Right. It is. What about using it in chilled water applications?
You can still use it in chilled water applications, and it's perfect for that.
Yeah. The only catch is you're now running your cold supply water through the bottom. So
cold, hot on top, cold on the bottom.
Cold on the bottom. But now in a chilled water application, the cold water is the supply out to the system. So you're going cold out through the bottom and hot return through the top.
Back in through the top. Yep.
Cool.
Reverse application, but same concept.
So I think you covered the piping pretty well and just on how this system works, but what about sizing?
Sizing, boy, we get a lot of questions about sizing
all the time.
And it's really pretty easy if you understand what your system requirements are.
Right. Let's be honest here. I mean, it's always easy to look at it and go, well, it's 2-inch pipe. I should have a 2-inch separator.
Exactly. Yeah. A lot of guys think, you know what, we're going to size it based on pipe size. And what you really need to look at is what your flow requirements are for your system side and your load side. And that's probably easier in a new construction or new build scenario where you're designing the entire system. But when you get into retrofit application, maybe not so easy.
No, it's not. And that's probably where we get the most amount of questions about sizing is, hey, I got this old system. It's got all this old iron pipe in it, you know, so there's a ton of things to weed through with that.
Right.
It's got a monster pump on it.
Yeah.
So, okay, we already know that this building may or may not have gone through how many remodels, updates of windows, added insulation, all these different factors.
Right.
It was already oversized to begin with
Possibly,
the pump,
probably
with the pump, the piping,
right.
you know, maybe even the boiler. And now they're stepping down to a pair of smaller modulating condensing boilers.
Right.
There's a lot going on with stuff like that. So going back to what we were saying, you want to size it off your greatest flow rate of the two.
Right. So you'll look at your boilers and essentially you'll come up with a design flow rate for your boiler or multiple boilers, depending on your application. But then you got to try to do some engineering and figure out what your load side is and come up with a flow rate there. And then once you do that, you're going to pick the larger of the two flow rates and you're going to size based on that.
Yeah, you have to size it correctly. I mean, you definitely do not want to be undersized.
No.
Yes, a hydraulic separator is a vessel where typically velocity drops, but if this thing is sized too small, you're going to create a pressure drop through that, and
right.
That's going to create a problem.
Right, exactly. Well, and when you look at, you talked about sizing off pipe sizing. Well, that can really get you in trouble because, I'm going to use our 2-inch as a perfect example.
2-inch is the perfect example.
Because our 2-inch union body connection is rated to 39 GPM.
Right.
But you look at our 2-inch flanged.
That guy's good for 60.
60. Yep, 60 GPM.
Yep.
So that's where it's really important to dive deep into your flow rates and pick the proper flow rate.
Yeah, I mean, that's probably the one we get the most questions about is the guy looks at it and sees the price difference from a union model to a flange model. And then that's kind of where they pump the brakes and make the phone call and go, well, I don't want to spend more money than what I need to. And rightfully so, because that's what's going to get you your job. You come in there and quote the price, say you quote it wrong and you're the cheaper of the two guys. And all of a sudden that system's not working properly because you didn't go through and figure out the sizing correctly.
Well, you brought up a good point. So, guys picking a 2-inch model because of cost. Well, cost isn't why pipe size or cost isn't why you pick a product. You pick it because it's the right product for the application. So
exactly.
You may be able to pick that 2-inch union connection and save some cost when really you needed the 2-inch flange based on your flow rates. That's going to be your next problem job. So nobody wants that.
No. And then it ended up costing you, the contractor, the money.
Yeah, because eventually you'll have to come back and put the right product in to get the right performance out of your system. And that's when repiping, because, face it, the dimensions on a 2-inch union connection versus a 2-inch flange is greatly different.
Yes, it is.
And if you don't have an idea, give us a call and we'll help talk you through it.
Yeah, that's what we're here for. We'd rather have you guys make the right choice in product versus just winging it and going out there and looking foolish later.
Right, absolutely.
So now that we beat that one in the head here pretty hard, the other question we get is on installation. A guy goes in, puts this thing in, and he looks at it and says, that bottom ball valve looks like a perfect spot to pipe in the fill and an expansion tank.
Right. Yeah.
What do we say to that?
Definitely not.
No, not at all.
Definitely not.
And we have guys that'll question, well, why not? Well, let's think about this. If this is an old system with old iron piping and you didn't go through and do a flush on it, where's all that heavy deposit and debris coming from and going to?
Right in the bottom of that separator.
That's right. Even if it doesn't have a coalescing mesh in it, it's still going to be a sediment trap.
Right. Yep. Easy enough to just pipe that in on the return side on either side of that separator.
Right. Put it in the return on the primary or secondary side. As long as you don't have a pump pumping directly at that expansion tank and fill, you're in good shape.
Yeah, it's a good spot for it. Yeah, don't tie it into the bottom. You'll be in trouble.
Right. So the other question we get is just when you go to service it, you know, when you go to do a blow off on it for the first time, like on a SEP4, what is the protocol for that?
You mean like how often do we do that? You
Right.
know, that's the question I get. Well, how often do I flush it? How often do I?
We always get that question.
You know, and
this
I can't give you an answer on how often, but
No.
but my general comment to that is it really depends on your system. I mean,
Right.
if you're working with an old system and old iron pipe and radiators and it's a dirty system, you might be flushing it once a week. You might be flushing it once a day for the first week.
Right.
I mean,
that's the best answer we can give you, because we don't know what your water quality is like or the system. If it's nasty old, like you said, old iron pipe,
right.
and you didn't do a major pressure cleaning on it, if you don't do a pump it out and dump it and high pressure clean it, it's probably going to be pretty darn dirty. And now that separator is going to act as a kind of a filter.
Yeah, it is. Well, and I usually say that, you know what, start out, you know, if you're on site, once you get it operational, flush it once a day. You know, you're going to see what comes out of it. You know,
Right.
You're going to flush it until it runs clean for 10 to 15 seconds of clean water coming out, and then consider it flushed.
Sure.
You know, then maybe set up a time to come back a month later or 6 months later. And I think eventually you want to get the system to a point where when you're in doing your annual maintenance, you're doing a flush on the hydraulic separator and cleaning that.
Sure. Obviously, when you go to service one of these, you do a blowdown. You know, if you got a SEP4 or even a 548, but we'll use the SEP4 as an example because there might be a couple more steps in there. But no matter what, when you're doing a blowdown, pumps got to be shut off.
Yep.
System can't be running. Then you're either going to go with a bucket or a garden hose into a bucket or a floor drain. I'd prefer to see a bucket just because you don't want to see all that nasty debris going down somebody's floor drain and plugging it up. So purge off into a bucket after you shut the pumps off.
Yeah, make sure it's pumps on both sides.
Yep.
You know, you want to make sure that all your pumps are shut down.
Yep. And just open that. You pull the magnet if you got one with a magnet. The larger ones have a bayonet in the bottom. You just unscrew that bayonet and drop the bayonet out of it.
Right.
And then, or if it's the smaller union type, they've got that magnetic band. You pull that, you open the ball valve on the bottom, purge it off into a bucket until you see clean water, close it back up. System should autofill if you got an autofill on it, so it's taking care of that already.
Right.
Then you can restore it back into operation after you put the magnets in place.
Right. Yeah. I mean, pretty simple as far as maintenance goes.
Yeah. Well, anything else we should cover with hydraulic separators?
You know, I it's funny as you mention it. You know, I think we did a good job of covering what they are, how they work, how to install and maintenance them. As you know, a question comes to mind that I get all the time on tech calls. You know, we talked about not having a pressure drop across them. You know, we get engineers that call and they want to know what the pressure drop is. How do I calculate that?
There is a calculation on that. It's a tough one to try and do if you don't like doing algebra. And me, I'm not a big algebra guy.
Right. Yeah, there's a formula on our Ask Caleffi that you can pull up if you want to know how to calculate the pressure drop across the hydraulic separator, and it's possible. But I think that, you know, that you calculate it once, you calculate it twice, you're going to realize that it's so minimal, it's not even worth putting into your system.
And noteworthy is Hydronics number 15 on separation. If you guys want a little more information on separators, go check out Hydronics 15. I mean, you can pull it right up on our website as a PDF. You can read it whenever you want. I think we even have them available online as well. Like you could purchase.
You can download it, or you can go in and I think order a copy, but you can download a digital copy right online.
Yeah, it's pretty handy. There's a lot of great concept drawings in Hydronics 15.
There is, and it's not only hydraulic separation, it's separation in general. So it's going to talk about dirt separation that we talked about last week and the air separation we talked about the week before. So it's going to kind of cover all those topics in that one issue.
Sure. Well, I think that's it.
So, Greg, what do you want to talk about next week?
Well, Dan, I think we're going to talk about balancing valves.
Well, that's a great topic. We get a ton of questions on those.
We certainly do.
Well, we'll see you next week.
Yep. Tune in next week. Thank you for tuning in. If you ever need help,
Please feel free to contact our tech support team anytime at techsupport.us@caleffi.com.
or call us during our business hours at 7:30 a.m. to 4:30 p.m. Central Time at 414-238-2360.